The topic at hand is the transfer of energy within and on the planet. And we like to look at it in terms of the four spheres that people speak about: the geosphere, the biosphere, the atmosphere, and the hydrosphere. And each of those have their cycling of energy within them. And what's interesting to me is that there's really only a few ways to move energy. We either do it through conduction, through radiation, or through convection. And so all of those things are what we see on the planet, and they all interact in weird and wonderful ways. And let's start with the geosphere, where the major thing going on is convection. And that is because the core is extremely hot. And so the mantle, which we've talked about in the past, is not molten. It's a viscous solid material. If it was molten, we would have sunk and we wouldn't be here. But it's a viscous solid. And so that all of that heat that has to get out of the core, which is there because of the initial heat of making the planet and because of radioactivity. So we have continuous radioactive decay. So we're sitting on a big nuclear power plant and it's generating all this heat, and that heat's getting its way out. As it does that, we have plumes coming from the core mantle boundary and rising up. Those things are then cooling, and that sets up convection. The other part of the convection is that as the plates are subducted, they're taking cold material down. So convection is very simple. We see it on many different scales. Things get heated up, they become less dense, so they rise. Once they get up somewhere, they cool off, they get more dense, and they sink. So it's a circulation system. It's the pot boiling on the stove. So the mantle is convecting, and that's part of the plate tectonic story. And the plate tectonics, subduction and forming new crust, and heat that comes out of the planet to the surface is really only seen in a couple places. One is at divergent boundaries, where we're making new crust with basalt coming up into the ocean. That's putting heat out. The other is at subduction zones, where we have arc magmas coming up. Those magmas carry a lot of heat. So we look at a heat map of the planet, just thinking about the geosphere, we see it along the mid-ocean ridges, and we see it at the volcanic arcs. And that is transferred, certainly, but it's not a big part of where we live. We don't necessarily notice the heat of that. That's because we live on a continent that's quite thick, 50 to 80 kilometers thick, and it's a good insulator. So in general, we don't see that heat. However, we do see radiative heating from the sun, and that's the major story if we get out of the planet and onto the surface. And that means that wherever there's sunlight, if we get plenty of it, it'll warm up and you can get quite hot, as I'm sure we all know. That then sets up convection, because once you heat air up, then it gets less dense and it rises, and then it goes up and cools and sinks. So we have convection going in the atmosphere, right? And so those are the two main processes, along with conduction, which means if you heat something, the heat will go through it. So you heat the soil up, and the soil will warm up from the radiative heating from the sun, and that will be conducted through the earth. So what's interesting is we talk about the geothermal gradient, how fast it gets hot as you dig into the earth. That's an interesting thing, because if you go outside and you start digging a hole, it will initially get colder as you dig the hole. That is because of the radiative heating from the sun. Once we get away from the sun, it gets quite cold down there. So if you want to store vegetables or wine or anything to keep it for a long time, you put it in a cellar. And so that means we're getting away from the radiative heating. And if we keep digging, eventually it'll start to warm up, because we'll get into the heating from the geosphere, from the mantle. And so that sort of sets up this idea that the atmosphere is convecting and circulating, and the oceans have this incredibly complex circulation pattern, where we have upper streams moving this way and then, and deep cold water, and places where those things up well, like off the coast of Peru, there's great fishing because they bring up all that deep water, and all the fish go bonkers. All of the cycling of the oceans is happening, and what's interesting is it's always changing. So as the continents have moved and changed, and as the planet has evolved, the plate tectonics and breaking the super continents up, that circulation changes, and it will change again. And so some places will be different. It'll affect the weather, because as you know, When you're near the coast, if it's warm water, or cold water, it affects the temperature where you live. But the oceans, the hydrosphere, they're circulating like crazy. The atmosphere, it's convecting like crazy. And then, of course, in the biosphere, we're mostly dealing with heat from the sun. And then, of course, critters living in it and burrowing in it and things like that. And so this cycling is mostly within the spheres, but the spheres do overlap a bit by mostly convection.